All right, let's get into it. For today's deep dive, we're looking at something pretty specific. DVIGear's DVI-2520-AOC active optical cables. And the central question, really, for anyone in professional AV, is how do you get perfect 4K video at 60 frames per second over a really, really long distance?
And that's the absolute wall you hit with traditional wiring, right? Your standard copper HDMI cable, it just can't handle that kind of bandwidth past, what, 30 feet or so?
Not reliably, no.
So you have to have a solution like this, an active optical cable or AOC. There's really no other way.
Exactly. And the source material for this one, they're calling it Hyperlight. The promise is basically top-tier performance in a package that's tough, but also light. This is about breaking past those old limits.
So let's talk hard numbers.
Yeah, let's do it.
The performance here is pretty impressive. You're looking at data rates up to 18 Gbps.
Okay, so that's the full current spec for high-end signals.
That's everything you need, and it extends that signal up to 328 feet, 100 meters.
100 meters?
Hmm.
That's massive for a plug-and-play solution. And it's not just about getting any signal at that distance.
That's right. It's about the quality, the integrity.
It's fully HDCP 2.2 compliant, which you'd expect, but it also handles the really detailed color specs. So you get that full 4.4.4 chroma sampling.
Yeah, or for HDR, you've got 4.2.2 10-bit color, and that's crucial if you're working in post-production or with these huge, complex video walls.
Absolutely. So maintaining that signal over the length of a football field is one thing. But what happens when you run it next to, I don't know, a bunch of power lines?
And that's where the construction comes in. It's a hybrid design.
Okay, so unpack that for us. What does hybrid mean here?
It means you've got optical fiber for the really important stuff, the video, and then copper wires for the lower speed data and the power.
Right.
And because the video pass is purely optical, it's totally immune to all that environmental noise. You get a very low RFI beam profile.
Which is a huge deal for secure locations. Think server farms, government buildings, hospitals.
Oh, exactly. Any place where signal leakage is a liability, fiber basically makes that whole problem disappear.
Okay, so fiber for video, copper for power. Makes sense. But what's the trade-off? Do you get the fragility of old-school glass fiber?
Well, they've engineered around that. They use plastic optical fiber, a POF, which is way more durable. And for power, the consumption is tiny. It's less than 0.235 watts.
So it just draws power from the HDMI source itself.
Yep. In most cases, you don't need an external power supply. It just simplifies everything for the installer.
Speaking of installers, ease of installation is just as important as the performance specs.
Oh, absolutely.
And the sources say these are UL CMPOF compliant.
Which means they're plenum rated. You can run them through commercial air handling spaces without any issue.
That's a non-negotiable for a lot of jobs. And they're flexible too, right? I saw a number that seemed almost too good to be true.
The bend radius, yeah, it's 2 millimeters.
Wait, 2 millimeters? For a fiber optic cable? That's insane.
It means you can basically make a right-angle turn without worrying about snapping the core. It gets rid of a ton of installation anxiety.
And I saw something about removable connectors too.
Right. The HDMI heads actually come off. And what's left is this tiny little cross-section, about 12 by 10 millimeters.
So you can pull it through a really narrow conduit.
Exactly. It's one less failed pull, which saves a ton of time and money on a big job.
So if we're boiling this whole deep dive down, it sounds like there are three key takeaways. You've got speed, the 18 Gbps. You've got reach 100 meters for perfect 4K.
And resilience.
And resilience. Plenum rated, super flexible, and that ultra-low EMI for secure installs. I feel like they've packed all the complexity into the cable so the installer doesn't have to worry about it.
And that brings up a final thought for you, our listener, to sort of chew on. We're seeing fiber optic tech solve these huge problems of distance and interference for video. So, What role is left for high-speed copper in the future? As standards keep advancing, is the future of short-run connections all about these hybrid solutions, or does pure copper still have a critical part to play in those last few feet?